Namaskar, Adab, Sastriyakal. How are you, students? So we are studying electrostatics. That is one of our most important topic. And what are the topics that we have covered till now? We have started from Coulomb's law. First, we have studied about some basic properties of charges. We have completed Coulomb's law. We have completed electric field. We have completed now about energies also. We have seen some varieties of concepts that we can come in potential that we have covered. We have seen about the relations also. What was the relation of, if I will tell you, what was the relation, one very important relation is there between electric field and potential. What was that relation? That relation was given as delta V. Oh, where is the pen? Why it is getting so slow? Why it is getting so slow, yeah? What is happening, students? Okay, let's start. So what was the relation that I hope that there is some glitch in that. What I can say that work done or potential difference can be written as minus of E dot dr. That was a basic relation that we have already seen in this topic. Okay. Now we are going to start a new topic, that is what? That is equipotential surface. Now what is equipotential surface? From the name itself it is very clear about what is the name. Divided into two parts, equi plus potential. I think I have to take the pen. What is the name? It is equipotential surface. Now what is the meaning of this equipotential surface? Equi means equal or same. Potential already you know. That means it is a kind of surface or a body which have the same potential at every single point of that body. That kind of bodies are called as what? Equipotential surface. If I am talking about the definition that you will write in the board exam, that is also given. It is a locus of points those who have equal potential. Those all the points. Locus means what? Locus means connecting all the points where the points are moving. If you are connecting all those points, it will create the locus of that point. Locus of that point, we are having equal potential. Work done by electrostatic force will be what? For example, let's understand that also. Let's suppose this is your electric field going in positive direction. Okay, and I have made a body. Okay, I have made a body somewhat like this. In 3D it is. So imagine this system is in 3D. Okay. So now what I will say, if I am saying that this body is equipotential surface, this plane that I have introduced, and this is a complete 3D thing I am talking about. So if it is a planar surface and I am saying that it is equipotential surface, what I can say that potential at point A and potential at point B have to be equal. That is what, that's it, the meaning of equipotential surface, as simple as that. That the potential at point A and potential at point B will be equals to equal. So if I will ask you, tell me, if I would take a charge from point A to point B, what I will write the work done? So what is work done? Work done is equal to Q into delta V. Correct? Minus of Q into delta V. That means VV minus VA. Correct? VV minus VA. Now what you can say about VV and VA? What is the relation? Can you say both of them are nothing but equal? If they are equal, can you say both of them will be cancelling out each other and the final work done will be coming equals to 0? Correct? Now next point. Electric field is always perpendicular to equipotential surface. Let's suppose the board's exam you are having this question to draw some equipotential surface. Some basic properties you have to remember. So one of those properties, very important properties, are whenever you are drawing an equipotential surface, the surface have to be perpendicular to the direction of electric field. For example, the surface that we have drawn, if you will notice it properly, what you can see here, that these lines are perpendicular to the direction of electric field. For example, let's take an example. I have taken a paper, white sheet of paper. Okay, I have taken this white sheet of paper, and if now I want to draw a equipotential surface, let's suppose this is the electric field that is going, and this plane is the equipotential surface. What I am trying to explain, that this electric field will always be perpendicular to this plane, so planar surface. You can see what is the angle between them. If I am talking, this is a white sheet of paper, this is behaving like a planar surface, and this black pen is behaving like in direction of electric field. What I can say about it? Both of them are mutually perpendicular to each other. So this is a very important property that you always have to remember. Correct. Next point. Potential on all points on the surface S1 and S2 will be same and S2. What the second point is saying, it is the same thing that we have already discussed. That potential at all the points on the, it doesn't matter only A and B. Take some point C, take some point D. At all the places potential will be same. Potential will be same. And if I am talking about this one, let's suppose at some point potential is S2. That means at all the points that are present on this equipotential surface, potential will be S2 only. Correct? So this is some basic properties of equipotential surfaces. Oh, it is some amazing transition. Don't you like it? Amazing, amazing. Okay. But I don't know where our pen went. Our natural pen is not coming. We have to manage from this only. Now for different kind of bodies, we have different kind of equipotential surface. For example, first one is for a point charge. Let's suppose you are having a point charge plus Q. That means now the question may be arise that what kind of equipotential surface this point charge will be having. So this point charge will always have a spherical kind of equipotential surface. That means what I am trying to say. See, if you will see this diagram properly, here is a sphere I have made. Okay. Now why I am saying that all the points will have same potential? When you are going at some r1 distance from this charge, you go at in any direction r1. This is a sphere. One more thing, students, I am talking about the 3D diagrams. I am not talking about 2D diagrams. This is not a circle. This is a sphere. If this is a point charge, I am talking about in all the directions, all the 3D directions along this point charge. All those points will have the same potential. All those points will have the same potential. Let's suppose if potential is V1 at this point, I can say potential at this point is also V1. Potential at this point is also V1. Correct? Now, if I am taking some different, now I have changed the radius. Now I am taking the radius that is taken as R2, and now I am going in complete 3D direction and connecting all those points. It will give me what? A sphere. A sphere. You can how I can make that? You check. When you will be calculating potential at this point, potential at this point, potential at this point, potential at this point, all those points will be coming same potential, and when you will be joining all those points completely, it will finally you will have a sphere surface. That's why I am saying that a point charge, always remember what you have to remember from here, that a point charge always have a spherical equipotential surface. Remember this very important thing. Correct? Now, so what will be now second point here is what? Work done by electrostatic force. What will be the work done by electrostatic force? Work done from A to B. From A to B. See, where are the firstly identify the points A and B. This is what? Point A. This is what? Point B. Now the question is asking you what will be the work done in taking the point from A to B. From taking it from A to B, what will be the work done? Can you say work done from taking A to B? I can write U initial minus U final. And this is very obvious thing. Now can I say I am on the same potential, or same thing can also be written as Q times of V initial minus of V final, correct? And can I say it initial point is A, let's suppose, and final point is B. From A to B I am asking, and I can say that both are same potential. That means can I say both will be cancelling out each other? Yes or no? Aaya na? Samajh aaya? I hope that this much of Hindi you people know that you can understand this. So what I can say about the work done, total from A to B, 0, simple. Now, if the question will be asking me, tell me what will be the work done from B to C. From B to C, what will be the work done? Now this time it will not be 0. Reason? Because this is a different equipotential surface, this will be a different equipotential surface. How you will write? You will write Q times of V initial minus of V final, correct? Or minus times of Q into V final minus V initial. A lot of time different kind of now you can take care of that. So what you write? Q. Now V initial students, this is point B, this is initial point, this is your final point. How you will write? What is the formula of potential? KQ by R. I have told you it is defined as, again I am explaining. V can be written as U divided by charge. What is U? K Q Q divided by R divided by Q. This Q and Q will get cancel out, and what will be left? KQ divided by R. Correct? If KQ divided by R, that means what you will write here? Initially KQ divided by, now what is the initial length? You can write R1 minus KQ divided by, what is the final length? R2. This will be what? Your work done finally. Correct? This will be what? Your work done. So this is all about equipotential surface. Let's see some more properties for different bodies. Oh, it's nice. It's looking very nice. Now, for a wire, let's suppose you are having a wire. Due to that, what will be the equipotential surface? For a wire, what kind of equipotential surface that we will be having is, what is this? Should we try? Okay, this is marker. Fine. For work done by moving a charge in from one point to another by equipotential surface is 0 because of C. What is given? For a rod, if this I can explain by this. Imagine this is the wire. Okay, this is the wire, and I want to find a equipotential surface. What is the property of equipotential surface? That on that surface all the points should be have the same potential. That means, can I say that all the points should be at the same distance also from this wire? Now this is a wire. Now I am going in this side. I am going in this side. I am going towards you. I am going towards me. At some R or some fixed distance, I am going in this direction also, this direction also, this direction. So like from all the points, all these distances are same. Can you imagine if I am connecting all these points around, what is the shape I am getting? Tell me. What is the shape you will be getting? Imagine in 3D. What kind of shape you will be getting? Can I say you will have some cylindrical shape? If you are connecting all those points around a wire, can you say you will be having what kind of shape? Cylindrical shape. So what kind of equipotential surface you will be having? See, if you are going from here to R distance, you are coming out of the box from R distance, you are going here at R distance. Can you say it will make a equipotential surface? And all the points on this equipotential surface will be same. So now if you are taking, let's suppose, any point from point A to point B, what will be the work done? Work done will be 0. Why work done will be 0? Because point A and point B both are at the same potential. Correct? Basic thing. Fine. Now for uniform electric field, what kind of equipotential surfaces you will be having? It is very simple. Where is our pen? Firstly, let's take our pen. For planar surface, what kind of for the electric field, uniform electric field, we'll see. Field due to uniform charge conducting and non-conducting sheets, vice versa. Let's suppose if you are having a uniform electric field going like this, you remember what kind of equipotential surface? Equipotential surface should be perpendicular to the direction of electric field. If I want a perpendicular direction, can I say this kind of some planar surface will be there? This kind of some planar surface, if I am imagining this in 3D, I can say this is my electric field direction and this is my planar surface, and all the directions, all these points are perpendicular to each other. So always remember, if there is some uniform electric field is given to you, that means what kind of equipotential surface you will have? You will have a planar surface, plane equipotential surface, or you can also say these are what? These are nothing but planar surface. What kind of surface? Planar surface. Correct? Great. Now let's understand these things with some basic problem. Okay, let's see. Okay, question is getting hidden. Now it's fine. Some equipotential surface are shown. Find the magnitude and the direction of electric field. Direction and magnitude of electric field you want to calculate. Okay. And what kind of system is given? This is the x-axis, this is y-axis. Three equipotential surface, that means uniform is there because planar surface are the equipotential surface. This is clear. What are the potentials going? 10 volt, 0 volt, minus of 10 volt. That means it is decreasing in this way. If I am saying that. You remember a very important line I have told you in the last lecture. At the end of the last lecture, I have told you a very important line. What was that line? Okay, if you don't know, you have to go and watch that. That was a very important line. I have told you also that you have to check that. The important line was that electric field always travels from higher potential to lower potential. Higher potential to lower potential. That means I can also say that in the direction of electric field, potential always decreases. In the direction of electric field, potential always decreases. Now see, what are the two possibilities? Either it will be going like this. So can I say in this direction potential is decreasing or increasing? I can say increasing, but it is not true. So I have to go in this direction because in the left direction or in the negative x-axis, potential is continuously decreasing. So I can say this will be the direction of our electric field. One thing I got, that direction for electric field is minus of I cap. Correct? Now second thing, how I can find the magnitude? Magnitude is written as delta V by delta R for electric field, because we have known the relation that E is equal to minus of V is equal to minus of E dot dr. Correct na? So electric field, if I have to write, I can write simply as dV by dr. Now electric field can be written as dV. What is the change in potential? Change in potential is 10. What is R? R is what? 10. But 10 it is not in standard units. That means you have to convert into standard units divided by 100. Now check what will be this standard units. If I am calculating, this will be what? 100 Newton per coulomb. That is the units. If I have to code the final answer as complete in complete vector form, how you will write? I will write the magnitude part, that is 100, and the direction was minus of, this minus is reflecting what? That it is going in minus of I cap direction. Correct? And of course the units will be Newton per coulomb. Yes or no? Is it clear? Is it clear? I hope that it is clear. It is a very basic example that we have learned here. Okay. Now see, now the next and very important topic is dipole. The next and very important topic I will say, that is dipole. What is dipole? I think that if you have studied about chemical bonding in chemistry, you know the basics of dipole. I hope that. Okay. But now you are going to study the same dipole in physics. What is dipole? Okay. See, dipole, from the name itself, it is very clear that di means two and pole means polarity. Okay, that means any body, if it is having two polarity, this kind of system should be called as dipole, and exactly that is what happening. Dipole is made up of two opposite polarities. See here, NaCl component, you know, in chemistry you would have studied about it. I should make it NaCl. What is NaCl? It is Na is plus and Cl is minus. So can you say it is also a dipole? It is making also a dipole. Yes, it is also making a dipole. I can say here what? Here OH, this bond, can I say they are also making dipole? Yes, they are also making dipole. So what I can say, all the materials are made up of molecules and molecules are made up of dipole. So it is important to study dipole because it is a very basic property of any material, any bond or any kind of thing that is happening, which is having comprising. Dipole is a two opposite polarities basically, if I will tell you. One is negative charge, one is positive charge, and the distance between them is very less. That is called as dipole. Okay. So let's see further about it, how we are making a dipole, electric dipole. See, what is the definition you have to write? Two equal and opposite charges of magnitude q will be forming a dipole, and the distance between them is represented as d, and always we are taking this distance is very less. Okay, this is positive charge, this is negative charge. One more thing always remember, because the direction of electric field was what? Electric field lines I have told you, it always originates from negative charge and always, sorry, it always originates from positive charge and it always terminates at negative charge. Okay, but the direction of dipole that you will always make is from negative to positive. Always remember this direction. This is the direction for dipole. What is the direction for dipole? Negative charge to positive charge. It is separated by a distance d, dipole moment. Now, electric dipole is a vector quantity and the directions is negative charge to positive charge, that I already have told you, negative charge to positive charge. What will be the SI unit? Unit will be what? I will tell you. Dipole formula is, I guess that you already know. In chemistry in 11th PU1 you have studied about it. Dipole is nothing but multiply the charge with the distance between them. Charge is already magnitude wise it is same. Just multiply the distance between them. Correct? So if I will ask you the unit, what will you write? Q. What is charge? Charge can be written as coulomb. And what is distance? This is meter. That means, can I say coulomb meter will be what? My dipole. And if you want to see the visual representation very beautifully, here it is explained. See, I have told you that it is originating from a positive charge and it is terminating to negative charge. And this is the direction for the dipole. It is shown here that this is a dipole that is forming between positive and the negative charge. Direction is from negative to positive charge. This is what you have to always remember, students. Okay. Now let's see some applications. Some very good questions comes from dipole. Some derivations are important from dipole. So let's understand one by one all the cases. Okay. Don't worry, we'll learn everything. Firstly, first case. I don't know if some issue is coming in the board. Let's see. We have to calculate what will be the electric field at axial or the end-on position. At the axial or the end-on position. How we will calculate? See, firstly make a dipole very properly, it has been shown. And for calculation purpose, the distance we take between them is 2L, so that the calculations can become easier. Okay. The distance are taken as L to the halfway, and this is another L. Now we will be mentioning the electric field. Now let's mention the electric field. See, due to at this point, at point P, it is an axial position or end position. And second one is equatorial position. Equatorial position means what? If this is a dipole, let's suppose this is dipole, this is like this. From negative to positive, if it is going like this, axial position means either on this end, either on this end. That is the end position. Or equatorial position means perpendicular bisector. Here it is the equatorial position. These are the two positions where we are going to understand. For this case, what I will do, I will go by very basics. We already know how to write electric field. Yes or no? We know. Just trust me. You can easily write it. Understand with me. Now tell me, due to negative charge, what is the direction of electric field? Negative charge, you are always positive. That means what kind of forces? Attractive forces. Attractive forces radially inwards. So can you say this is the direction for negative electric field? Correct. Now what is the direction due to this positive charge? This positive charge radially outwards. Correct. Radially outwards. Now tell me which one and what is the direction of dipole? That also draw. Negative charge to positive charge. Now tell me who will be in majority. Who will be in majority? This is a very important question. This plus Q will be in majority or this minus Q will be in majority. I am talking about the impact of electric field that is coming here. I can simply say, because electric field is also inversely proportional to R square. If it is inversely proportional to R square, that means if radius is less, what will happen with electric field? Electric field will be higher. That means I can say simply that electric field due to plus Q have to be greater than electric field than the of the minus Q. That means I can say the net direction for electric field be in positive direction. Correct? Till here directions are clear, that I can say that this is the net direction that I am having at the axial position as electric field. Correct? Now let's see how we can calculate that also. See, I will write what? Axial position. Basically now my question is came down to what? Resolution of two vectors. Now let's resolve these two vectors. What I will write? Electric field plus Q minus of electric field minus Q. Correct? What you will write due to plus Q? What is the formula of electric field, students? KQ divided by R square. Right? KQ Now tell me, what about the distance between them? Now this is an interesting thing. What you will write the distance? Okay. What you will write the distance? From plus q, I can write this distance as, from the center I have taken the distance approximately r, and from here if I have to take, I will write what? R minus L. R minus L. And if I will ask you the distance from here only, then what you will write the distance? This complete is R and this much of the distance is L. That means what I will do? R plus of L. Correct? That means here plus Q, if I am writing the impact due to plus Q, I will write what? R minus L square minus of KQ divided by R plus L whole square. Correct? Now let's solve it. Now it is about mass. What you will do? You have to solve it. Okay. Now take the LCM. What you can do is, you can write in denominator, you can take it as R square minus of L square, and here you will do, just multiply here, R square plus, just tell me what it will become. Can you say R square L square plus 2R L? Correct? And what you will write here? Minus of, completely in bracket, you can take the eraser. Correct. Correct. Now here what you will be writing? R square plus L square minus of 2RL, and denominator it was a multiplication. Correct. Now solve it. What will be cancelled out? R square simply will get cancelled out. This L square also simply get cancelled out. Now what are the things that are left behind? Here you can say what are the things that are left is K, Q, in bracket here it is left my plus of 4RL. In denominator what is left? In denominator what you can say here, it will be R square minus of L square into whole square. I should write it as whole square. Okay. Now what are the things you can notice here? You remember what was the formula for dipole? Dipole was written as charge. What is the charge? Whatever the charge is there, into, multiplied by, what is the distance between them? What is the distance between them? 2L. Now notice here one thing. If you are properly notice here, what I can write this, I can write this 4 as 2 into 2, and I can write this 2 Q and this L. What I can write for all these three terms? I can write, at the place of writing these three terms, I can write this simply represented as P. So what I can do? 2 K P divided by. Now there is an assumption that I will be taking. I will be taking an assumption. What was that assumption? I will say that I told you that dipoles are at very close distance, like this. Only this much of distance can also be written as for dipole. So, and at the place I will assume that this R, here it is mentioned, R is a lot greater than this 2L distance. R is a lot greater than this 2L distance. That means, can I say this L distance will be simply can be neglected? So what I will do here, I will simply neglect. That means this term is tending to 0. It is very small. And here it is a term of R. That means in denominator now it will become how much? It will become 4 power R. This R and this will get cancelled out. What will be left? It will be left 2kp divided by R cube. 2kp divided by R cube. This is the formula that you have to remember for an axial position. This is very important, very important, students. As your board's point of view also, it is very important. 2kp divided by R cube. Is it clear? If you have still any doubt, do it by yourself. You will be for sure getting, and after that just practice some questions. You will be very comfortable into it. You can mention here the dipole directions also, because dipole is a vector quantity. Right? So you should be, it is a good practice that if you are representing it by a vector sign also. Now what are the important things that we can take it from here? We know that axial position, what is the electric field? This is a very important formula, 2kp divided by R cube. And what about the direction? Direction will be the same. You can write here also, write that also in a note. Make a note and write direction is same as the direction of dipole. Direction is same as the direction of dipole, correct? This is what I have to tell you. This is all about at axial position. I hope that this is clear, students. Now move to the next one. This is the complete derivation part that you can go, and finally when you will be taking all the approximation and everything, finally the result will be coming at axial position, that is equal to 2 kp divided by r3. Same thing that we have derived. Now come to the second one, that is equatorial position. What kind of, firstly understand what kind of position I am trying to tell. What is equatorial position? Equatorial position, if this is a dipole, like going like this point is showing you the direction of dipole, negative to positive. If I am taking at the angle bisector, sorry, the edge bisector of this will be here. Let's suppose I have taken this kind of points. This kind of points is called as equatorial point. This kind of point is called as what? Equatorial point. At this point. Okay. This point I want to calculate. Okay. Again, we are going to follow the basics. We are going to solve everything with basics. Nothing rocket science we are going to apply. Let's see how. Okay. Firstly, understand where is your dipole. This is negative, this is positive. Draw a dipole patiently. This is your dipole. Okay. Some theta and everything is mentioned. This is at a distance r. This distance is L. This distance is L. That means it is a bisector. I have already told you. And this point P I want to calculate. Firstly, mention the directions. What are the directions that are coming? Due to positive charge, what will be the direction? Can you say simply away? This is electric field due to positive charge. Due to this minus q charge, what will be happening? What is the direction of electric field? Can you say it will be a kind of attractive electric field due to minus q. Correct? Now, what is the next step? Always we have to do the same method. Always follow the same method. We have to now just simply resolve these two vectors. That's it. Done. Now let's make some angles also, and please listen carefully. Okay. It is very interesting. This angle is theta. What you can say about this angle? This angle is also theta. Now take components. Make this component. If this angle is theta, what I can say that if this is 90, this will be what? This is angle is also theta. That means what you can say, if this angle is theta, this is parallel. That means this angle is also going to be theta. Correct? Now make components. This will be E cos theta, and I can say what? Firstly write that also. What I can write for electric field due to positive charge. Firstly let's mention it. Simply, due to positive charge, this is a positive charge. Here is the point where you write electric field. How you will write? You will write K Q divided by the distance between them. What is the distance between them, students? This is perpendicular, this distance is R, this is L. And what will be the, that means this hypotenuse distance? This will be nothing but R square plus L square. And now when you are making the squaring, what you will write? Write it by R square plus L square. Okay? In writing, don't make laziness in writing. You have the habit of writing everything. Especially when you are learning it for the first time. It is mandatory to write the things, otherwise you will not be able to understand it. For negative charge, how you write? Negative charge, this is your negative charge, this is the point where you are writing. What is the distance, you can tell me? This is R, this is L. What will be this hypotenuse distance? This will be what? R square plus L square. Again, it is R square plus L square. Now tell me one thing. Can you say my question is reduced to, let's suppose this is E naught, this is E naught. I have to resolve this much only. Both are equal, and now the question is, this is some E naught, this is some E naught. Angle between them I know, theta, that's it. This is what I have to do. Now how you will resolve it? I will resolve it. You will take a component for this one, that will be E cos of theta, and this component will be E sin of theta. Correct? For this also not take components. This component will be what? E cos of theta. This perpendicular component will be what? E sin of theta. Now what you are observing here? That is, can you say this E sin of theta, both are going to be cancelling out each other. What is the net electric field is left? It is very simple. Net electric field is only left to 2E cos of theta. Net electric field is left only to 2E cos of theta. Because the perpendicular components got cancelled out each other. E sin theta is cancelling out E sin theta. That's it. Because it is very clear. Now one vector is in positive direction with 2 magnitude, one vector in negative direction with 2 magnitude, obviously the net electric field will be what? 0, correct? So let's write this result also. Till now we have raised till 2e cos of theta. Any space here? Oh shit, we have not given our space here. So I have to write at this place only. Here, if I have any space, here I have space, we are going to use this space for that derivation. Let's use that space here. Now, what was the E net we are having, students? E net we had was 2e cos of theta. Now write E. 2 into E. E was what? K Q divided by R square plus L square. Correct? And what was cos of theta? Cos of theta, how you write? See that also. Define cos of theta here. Can you write cos of theta in this triangle? Cos of theta. Oh shit. Cos of theta. Cos of theta can be written as base upon hypotenuse. Correct? What is base? You will write L. What is hypotenuse? You will write R square plus L square power of 1 by 2. This is what you will write for cos of theta. So let's substitute this value in here and let's see what is the result that we are getting. Here you will write about L divided by R square plus L square power of 1 by 2. It will be written as 2kql divided by R square plus L square power of 3 by 2. Now tell me, again I am going to do the same kind of things that we have did in the last scenario. What we have did in the last case? We will say, what is dipole? Dipole is nothing but equal to 2q into 2l, the distance between the dipoles. Now see, 2ql. What I can say for this complete term? This can be written simply as p. And what I will say that r is a lot greater than L. That means I can simply neglect this value L. Simply it will become 0. That means what is the part that is left? I can simply say Kp divided by Rq. Because now this will be happening what? Kp divided by Rq. This will be the result that will be coming at the equatorial position. This will be the distance that result will be coming for equatorial position. Now let's see, are we correct? What do you think? You also derive with me, along with me. Okay, correct. We are having Kp divided by Rq. Now there is a negative sign. Why this negative sign is coming? What is the impact? Did we have wrong? We have did the derivation wrong, or why? What is happening? Why we are getting this negative sign here? This is written as what? E equivalent is equal to minus of Kp divided by Rq. So why this negative term is coming? Actually you have to understand our derivation was completely correct. Everything we have did step by step. There was nothing wrong in that. Only thing that is changing is the direction. Because electric field is a direction property, that means it is a vector quantity. That's why you have to now see properly. This is a very important point also. What is the direction of our dipole? Negative charge to positive charge. This is negative to positive. This is the direction of dipole. But where the net electric field is coming? Where the net electric field is coming is in this direction. Let's show this also. Where is the pen going? If I have to draw the net electric field, I can say this is the direction for my net electric field. Correct? That means I can say that these are opposite directions. It is going in positive direction, this is going in negative direction, and that's why the negative sign is coming. That is reflecting that it is opposite to the direction of dipole. If you have taken dipole as positive, electric field will be in negative direction. So two very important things that we have understood from here. Magnitude will be what? Kp divided by Rq, by us taking all the approximations, of course, and the directions will be opposite to the negative charge, opposite to the dipole that you are taking. Correct? This much is clear. Okay. Now let's move to the third and the final part of electric field. At any general point, if I have to write dipole, how I am going to write? Okay. Now it have two methods. Okay. Let's understand from the easier method. What is the easier method? I will tell you. Very easy. Just listen very carefully, and whatever I am writing, just properly focus that and take a pen on paper and try to follow that one also. Okay. Just track what I am writing here. See, first we make the dipole. In all the cases we are doing the same thing. Make a dipole. From negative to positive charge, I have made a dipole. Negative to positive charge, I have made a dipole. Correct? Now this is point P. This is here point P. Okay. So can you say now, I have made in the at some angle theta. At some angle theta. Now we are going at complete general point at r comma theta. At some r distance, at some angle theta, I want to calculate what is the equatorial, what is my electric field. Okay. What I will do one thing. I will take two components. How I will take? This is P, this is angle theta. I will make a component that will be taking as P cos of theta, and I will make a second component that will be perpendicular to it, and that component will be P sin of theta. P cos of theta and P sin of theta. Now, if I will ask you at this point P, this is P cos of theta. For this dipole, what kind of position this point is? Very important question I am asking. Please listen again and again listen to it so that it can be clear only in the derivation part. This is P cos of theta, this is point P. What kind of point you are understanding? It is axial point or equatorial point? Exactly. It is a axial point because it is coming at the end of this dipole. Correct? Na? So it is axial point. That means, and what is the direction we know? This is the same direction as the direction of dipole. This is due to the axial position. Very good. Now, what about the second component? Because if I have solved for the two components, that means that I have got my result. This is P sin theta and this point is P. It is passing from the halfway of this dipole. That is what kind of position you can say now? What kind of position? Can you say it is equatorial position? And the direction for equatorial position, just 2 minutes back I was telling you, it is nothing but, what will be the direction? It is nothing but, it will be reversed to the direction of dipole. If this is the direction of dipole, I can say this will be the direction for electric field. Correct? So I got my two components of electric field. Now basically the question have reduced to resolving two vectors again. Now we can resolve easily, and how we will do that also see. So I can say, let's suppose this is the direction for net electric field at some angle alpha. At some angle alpha I am taking. Now what I will do, I will write both the electric fields. I will write electric field due to axial position. Now tell me what was the formula for electric field due to axial position. The formula was 2 kp divided by r cube. The formula was 2 kp divided by r cube. So what I will write here? I will write 2 kp cos of theta divided by r cube. Because at the place of p, what we are using? P cos of theta. At the place of dipole, what we are using? P cos of theta. And I will write this as equatorial component. This I will write as kp. Formula was what? Kp divided by r cube. This time there is no, and the direction will be reversed because this is in this direction. That means electric field will be in opposite direction. This will be what? Kp sin theta divided by r cube. Kp sin theta divided by r cube. And now what I have to do? I have to resolve these two vectors only. That is what I have to do. Okay. If I will talk about the angles, what is the angle between them? This angle is theta, correct? That means this angle is also theta. That means this angle is also theta, correct? Let's move to the next point. Let's complete this also. For component P cos theta, point P lies on its axis. Thus, electric field due to axial position, you will write what? At axial position, you will write the component 2 kp cos of theta divided by r cube. And for component P sin of theta, point P lies on its axis, actually at its equatorial point, and the electric field that you will write due to equatorial point is kp sin of theta divided by r cube. Correct? Now let's move to the next page. Now see, those were the two components, and can you say both of those components will be perpendicular to each other because they are axial. One is due to axial position, one is due to equatorial position. That means of course their angle going to be 90 degrees. So what I can say about the net electric field? Net electric field will be written as axial position square plus equatorial position square How you write axial position? Axial position we have written 2kp cos of theta divided by r cube plus 2, sorry, it's not 2, kp sine of theta divided by r cube, and this is also whole square, this is also whole square. Now this is what we have to resolve. Now this, after this, it is about complete maths. So what we will do, we will take the things that are coming common out of this in square root. Take firstly from here k I have taken common, p I have taken common, divided by r cube I have taken common, because all of them were having square. So after coming from square root, it will be simply like this. Okay, what are the things that are left here, students? I can say here it is what left, it is 4, because 2 square will make it 4 cos square theta, correct, plus of sine square theta, plus of sine square theta. So I know that there is a property, sine square theta can also be written as 1 minus cos square theta, 1 minus cos square theta, 1 minus cos square theta. That means finally it will be written as kp divided by r cube root under 4 cos square theta plus 1 minus cos square theta. That means it will eventually finally become, the result will be that you have to remember, it is kp divided by r cube root under 1 plus 3 cos square theta. This is the important result. And at what angle also it is coming? It is coming at angle theta plus alpha. The net angle from this horizontal, from the original dipole was what? Firstly you have taken an angle of theta, then you have taken an angle of alpha. That means total angle that you have taken is theta and alpha. And what is the relation between them? Tan alpha is equal to tan of theta by 2. If you have in doubt that how this angle is coming, let's discuss that also. It is very easy. There is a component, this was what? This is due to axial position, this is due to equatorial position. That means if you have to define tan of alpha, how you will write? You will write electric field due to perpendicular direction by electric field due to axial position. And this way you can write perpendicular upon base. Due to perpendicular, what you are writing? K p sine of theta divided by r cube divided by 2 k p cos of theta divided by r cube. R cube cancel, kp cancel. What is the thing that is left? It will be left only tan of theta by 2, and here it is what? Tan of alpha. Tan of alpha is equal to tan of theta by 2. That is what the equation is also written. So this is the final case for electric field, that is what you have to calculate. Any doubt, students? This is very important. Actually in board exam also sometime maybe the question is coming, and it is very obvious. We have derived everything from the complete basic. Nothing we have taken from directly we have written anything. Correct? I hope that this is now, it is getting into you. For better understanding, you have to practice it, of course, for by yourself. When until unless you are now writing anything by yourself, it will not be very much clear. I will explain you. You will also feel that okay, I got it everything. But when you are revising it after 1 week or 2 weeks, you will be forgetting everything. So it is very, very important that you are writing every single thing that I am writing here by your own hands. If you will be needing, we will be providing the notes also to you. So please make a habit of writing. Now there is some basic question. Let's resolve this question. Find electric field at point A due to dipole as shown. Due to this dipole, okay, there is some dipole at an angle of 53 degree. You have to find what is electric field. Now we are having the formula, so we are not going to derive it. What I will write simply, I will write electric field at any general position r comma theta. I know the formula, that is kp divided by r cube root under 3 cos square theta plus of 1. Correct? Now what I will write? K, any values that are given, K, P in general it is given, Kp divided by, what is the distance given? 8. Okay, great. I will write 8 into root under 3 cos square theta. 3 cos square 53. 53 is how much? 3 by 5. That means it will eventually become 9 by 5 plus of 1. Plus of 1. Correct? Now see. you can write here Kp divided by 8 root under 8 into actually it is 9. It will become how much? 27 plus 3, that is equal to 32 divided by 5. Okay, it will be root under, correct now? Theta root under 3 cos square theta, correct. I think that this answer is written as wrong. By mistake it is written. Finally, the answer that we will be quoting is Kp divided by 8 root under 32 divided by 5. Okay, it is by mistake it is written. This will be your final answer, because the result that we know that at any general point P, how you will write the dipole, you will write Kp divided by r cube root under 1 3 cos square theta 1 plus 3 cos square theta, you can write simply. So if you are doing that, you can simply calculate it, and this will be the final result that you will be getting, correct? Okay. So if now we are talking, let's quickly talk about the potentials also due to dipole. Now again we will have 3 positions. What are those positions? Equatorial position, axial position, and any general position also. Okay. Now if you understood electric field, now understanding potential is very easy. Let me explain. Let's understand the first one, at axial position. At axial position, how you write? Very simple. At this point you want to write, because why it is simple? Because potential is a scalar quantity, it is not vector quantity, so there is no problem of directions. And what is the value of potential? Potential is written as Kq divided by R. Okay, so tell me how you will write potential at point P. Net potential, you will write potential due to positive charge plus of potential due to negative charge. But tell me, what is the potential due to positive charge? You will write Kq divided by, what is the potential you will write here? You will write R minus L plus K Q divided by R plus L, and this is because this is a negative charge, that means you have to apply a negative sign here also. So you will write what? Correct, minus. Now solve it. What you will do? In numerator, take KQ common, and what will be left from here? R plus L minus of R plus of L divided by R square minus of L square. Now next step, what you will do? R and R cancel, 2 will be coming here, that means finally what will be in numerator? Kp divided by R square minus L square. L square will be anyways neglected, because always we are saying what? That R is a lot greater than L distance. That means what you can say, it will be tending to 0. In denominator it will be left only Kp divided by R square. This is what the potential at an axial position you will be quoting as answer. Okay. This is for first one. It is very easy. If you understood for electric field, electric potential is nothing. Let's see the next one. At axial position, it is even more simple. It is 0. Why? Very obvious thing. Tell me again you write potential at point P. It will be what? Potential due to positive charge plus potential due to negative charge. This time distance is also equal. How? Kq. Tell me, due to positive charge, what is the distance that you write? The distance is root under R square plus of L square. This is what you are going to write. This will be what? R square plus of L square minus of Kq divided by root under, what is the distance due to for this? This is R square. Can you say again the distance will be R square plus L square? That means distance is going to be R square plus L square. Can you say they will cancel out each other, and the final answer will be coming equals to 0? Correct. So final equivalent potential at the equatorial position is 0. Very simple thing that you can easily understand. Because there is no problem of directions, we can directly write these things. Come to the general position also. That is also very simple. See, you can write. If you remember, what was the first thing that we are doing? We will take a component for both these things. We will take a component, and what I am going to write? I will write this as P cos of theta, and sorry, this will be what? P sin of theta. two component. I hope that you know how to make component. This will be p sin theta, and this component will be what? This will be p cos of theta. Correct? Now tell me, for p cos of theta, what kind of position this is having? Axial position. For axial position, what is the formula for? Sorry, I'm changing the direction. What is the formula due to axial position? It is what? Kp divided by r square. That means here what you write? Kp cos theta divided by r square. Because at the place of p, it is what? P cos of theta. Second one. Due to perpendicular direction, due to this p sin theta, can you say this point is behaving like a equatorial position? And due to equatorial position, what is the dipole, students? It is zero. Correct? It is zero. That means, can you say net potential that is coming, that is only equal to Kp cos theta divided by r square, because there is no problem of any direction. So I can finally say my answer will be what? Kp cos theta divided by r square. There is no problem for direction. So this was all about dipole. I hope that now next point is only about the torque and the potential energy, potential that is required energy we will discuss. In torque, in dipole, how the energy is also there to rotate any dipole from theta 1 to theta 2. This kind of things we are going to discuss in the next part. So endigo and then they go nama tapasya. Until next time, keep learning, keep growing with tapasya.